Hi there, how are you doing? So in this video, we'll talk about how to create a table, what are different properties that we have while creating the table, and what properties are optional and what properties are mandatory is what we'll talk about mostly. So create table is something that comes under detailed statements. So if you remember in my first video, I have explained about different commands that can be executed in the database where I have classified all the commands into five different groups: DDL, data definition language, and then data manipulation language, DML, DCL, data controlling language, TCL, transaction control language, and then DRL or DQL, data query language. So under the DDL, we have five different commands: create, alter, drop, truncate, and rename, out of which create is the first one. So in this video, we'll talk about create alone. So this is the syntax, how we're going to create a table, and these are pretty much all the properties or attributes that we can specify while creating a table. And if you see anywhere I have the angle brackets, this means this particular property is mandatory property. Anywhere I have square bracket, that means it is optional property, right? So if you look at this, create table are keywords. So we are saying that create table followed by a table name, which is mandated to be specified. And do notice that always a table name should be starting with a character. We cannot start with a number, right? So, and then earlier we used to have the limitation that a table name can only be created up to 35 characters. I think recent versions it has been overcome. However, do check it. So we can specify here the table name, whatever the name we wanted to give, and then we have to open the parenthesis, which is mandatory while creating the table, and followed by each and every table should always have at least one column. So in this case, here, this is mandatory, which means that I should have at least one column, and each and every column should also have data type. So what is data type here? So whenever we insert the data into database, so we are trying to make the database understand what kind of data are we storing in a given column. Based on the nature of the data and the data type what we specify, we'll have few other options which will help us to get a better performance. For example, let's say that we are trying to store a character data which can have the nature of having uppercase and lowercase letters, whereas if it is a number, uppercase and lowercase properties are not applicable. However, if it is a number, the way how the data gets when we want to retrieve is going to be different versus scanning the data, which is a character data type, right? So likewise, like we have different data types that we can specify, and I'll have a separate video talking about alone the data types itself. So imagine that like we have the data types like numeric, character, and var character for now. So now we know that at least one column needs to be created, part of a table. It can have a data type, and the data size is optional. If you look at here, the reason is for some data types it is optional. If you look at a numeric data type like number in Oracle database, it is optional to specify the data size, which means that it takes the default size of 38 digits. However, if we want to use character and var character, then it is mandated to specify the data size. That's the reason I have mentioned it optional, which means that it may or may not have the data size always, and it depends on the type of the data type what we are using. And then followed by, we can also specify if we want a column to be populated always with a default value. When we say default value, that means we are kind of populating with a static value, right? Let's say that I have country. If my application is always going to run in India, and I know that I'm only going to have the people purchasing from India only because I don't do the business outside India, I can say that I can specify the default value for country is going to be India. However, later if someone wants to insert some other value which is apart from India, still it can be inserted, right? So if nothing is specified, it can take the default value. That's where we can specify default clause. And again, if you look at it, this is something optional. Then followed by, we can specify null or not null, which means that we are trying to indicate whether the column will accept null value or not. If we say null, that means by default it will always hello the null value. If we say not null, that means that it will not accept any not null value. So in Oracle database, if you don't pass any value to a column, that means it is going to have the null value which is undefined. And if you don't populate any value, it will throw an error stating that the column cannot take the null value in case property of a column is not null, right? So this is something about like at a column level, what are different properties that can be specified, and then followed by we have something called constraints. So we can also add constraints. We'll talk more about it, what is constraint and all, but we can specify the constraints at the table level while creating, which is to enforce whether a column is going to have always a unique value or not, or whether that's a primary key or not, or what are the value we are entering in a column in a table, whether it is going to be matched with the other table. In case if it is not existing, then we want to throw an error. So that's where we call it as foreign key, right? So we can use the foreign keys to reference the values of a column into another table. So there are some constraints to use the foreign keys and all, which we'll be talking about in later session. But we can define a constraint while creating a table. In fact, we can add the constraint later on if we want. We can drop it or we can create it. This is something not mandatory, and we'll be talking more about it in later sessions. And then followed by we have closed the bracket. So till here, the table syntax has been defined. However, this is only with respect to the column, its data types, whether the column accept the null values or not null values, and the constraints. Followed by, if you look at, we have something called table space. So if you remember in my previous video, I explained about what are different layers that are involved in the database whenever we save the data. So in that, the main property or the main component that we spoke about was table space, and here we can specify the table space. And again, this is optional, not mandatory. The reason for this is always a schema gets associated with a table space, which means that if we don't specify any table space property while creating a table, by default it is going to be created in the table space that has been associated at the schema level, right? And then followed by we have PCT free, PCT use. This is very important. I really want to talk about it, and this is from the performance point of view. So, what is PCT free? PCT free means, let's say that whenever we create a table and insert a row, it is going to be inserted into the block. Again, this is something I have explained in my previous video. So, part of storage layers, the least node where the data gets stored is called a block. Let's say that I have a block of 8 KB and I am storing the data in that block. I can specify that I always reserve 10% of the space from the block for future updates, which means that if I have a column which can take null values, which means that when I'm populating the data into the table, I may not specify the values for a given column. However, I can come back later on and I can update the row to have a proper value in the given column. In such kind of cases, this PCT free will be used, which means that whatever the space we have reserved in the block for future updates, using that space we can store the value in the same block. So why do we need PCT free, right? So think of this way that if we don't specify it, what happens is the value can be stored in a new block. The future updated values can be stored in a new block, which means that now one single row of a table is going to be stored in two different blocks. So what happens? What's the disadvantage of storing one row in two different blocks? So we have to read two blocks data just to read one record, even if we want only one row from the table. And that means if the block size is 8 KB, we will end up reading 16 KB, whereas my row size hardly can be probably like few bytes, which means that I'm reading more data than what is needed. Instead, if I always specify PCT free 10, for example, 10% of the block space is reserved, and because of that, in future, whenever I do perform an update, the values are going to be updated in the same block. That means I will end up reading only one block instead of reading two different blocks, right? So that's why it is always important to specify the PCT free. However, it's not necessary that we should always specify 10%. It depends on the application, whether you are using OI, I mean, whether you are creating an object or a table in OLTP database or OLAP database. Usually, when we say OLAP, it is data warehousing databases. In case if your table is getting created in data warehouses, subject to have too many columns, your block size can also be more, and the number of updates that you are performing in the data warehouse will always be less, which means that ultimately you can have probably like 10 to 15% or 20% of the PCT free. However, if your database is OLTP database and you're going to frequently update the data, then it is always to have more space reserved so that it can keep taking the updates, right? And similarly, we have PCT used, how much a percentage is used while inserting. And then we have init trans and max trans. Again, this is very important. We should be familiar. Init trans stands for initial transactions, which means that how many concurrent sessions can be used to connect and query the data from a given object. Let's say that I have created an employees table, and if I specify initial transactions is 1 and then maximum transactions is 10, that means that at a time 10 different people can connect to the same database and they can perform the operations on top of the same table. They, it is not necessary that whatever the operation they're performing are going to impact the same rows. If that happens, then we have something called row contention. We'll talk more about it in later sessions where I'll talk about all the logs, how a log works, what are the different types of logs and all. That's what is also called as contention. However, here we are talking about when multiple people are trying to update or perform transactions on the same table simultaneously. At that time, it can be started with one person, and maximum of 10 people can start connecting to the same table and perform maximum operations, 10 operations, right? This is called initial transactions and maximum transactions. And then we have something called logging and no logging. So if your application, either it is OLTP or the OLAP application, it is always advised to have logging. This is very important from the database administrator's point of view. The reason is, let's say that tomorrow, what if the database crashes and you want to restore till point in time the crash has happened, whatever the changes were there, everything has to be restored. Then it can only be done by reading the changes from the log files and then updating it to the database, right? If something hasn't synced up, and in that case, if you don't have the log files, which is nothing but archive logs, then you will end up losing your changes. The same way, let's say that you have a secondary database, and from your primary database, whatever changes happens needs to be sync up with the secondary database. Then again, if you don't have the logging, you will not be able to record any changes, and you will not be able to apply the same changes onto the secondary database. So it is always advised to use logging. Next thing we have compress and no compress. So let's say that um, you're going to have redundant values stored, and you have a wide number of columns, maybe let's say the 200 or 250 columns. If you do not compress, your table size may go up to terabytes. In such kind of situations, if you compress the table, again there are different types of compressions which we'll be talking about later point of time, but by compressing the table we can reduce it even up to 110 or 110 um, 10% or 20% of the actual size, which is a great saving. And that also helps you when you want to read the data, it can be read very well. If you specify compress, it gets compressed. If you specify no compress, the table will not be compressed. And by default, it is always no compress. Similarly, for logging and no logging, by default, it is always logging. And then any trans and maximum number of transactions, we always have default values as we can see here. The initial transactions is 1 and maximum number of transactions is 255. And PCT free by default it is always 10, and we can change it if we want to change it. And all these properties, whatever we talk about all this while, they are optional parameters, right? And then we have something called partition. So a table again can be partitioned, but there is a condition. The table has to be partitioned at least with one single partition in case if we want to split it further into multiple partitions, otherwise we cannot do it. And I'll talk more about it when it comes to partitioning concept. For now, remember that a table can be partitioned and there are different ways we can partition it. I mean, like we can use range partition, list, and hash partitions. And there is something which is very called as table space. So when we create the partitions, each partition we can store into different table spaces in case if we want. So that means our table is sitting in a different table space. However, when we partition, each partition can be mapped again to different table spaces. So your data actually gets stored into the table spaces, which means that your table doesn't take any space with the actual table space name that you're providing at the table level, but it assume and store the data in the table space that is. And then we have something called extents. So again, this is something I have explained about when I was talking about different database layers that are involved in the storage. So we first have table space. Underneath table space, we have segments. Underneath segments, we have extents. Down to the extents, we have blocks. So here we are talking about extents. So remember that we always have one segment for a table that has been created. Have um, large objects that are getting stored. In case of large objects, we'll have multiple segments, but otherwise, if it is going to be always one single segment, and that segment can have extents. So an extent is nothing but how many blocks should be reserved against a table the moment it has been created. So let's say that by default it is going to be 8 blocks when the table has been created and it is empty, and each block size is 8 KB. That means by default we are reserving 64 KB of memory for a table the moment we create it, right? And as and when we keep inserting and the number of blocks that are assigned to the extent are fulfilled, then we are how set of blocks or bytes has to be extended part of next extension. That's what we are specifying next here. And then to what extent it has to keep growing, and then how much of PCT free again that we want to reserve, right? And then at last we have a couple of more properties, that is on commit, delete, preserve rows. And if you mention here, I have mentioned that, like, sorry, if you look at here, I have mentioned that for global temporary table only. So there is a special kind of table called global temporary table, which is a feature of Oracle database, and I'll talk about it in a separate session. However, it has this option on commit. That means that, and we hit the commit command, whether the data has to be preserved in the table or the data has to be deleted from the table. So ideally, when we commit, we are supposed to store the data, but we are specifying that whether the data has to be preserved or it has to be deleted. And as mentioned, because that's how the global temporary table works, we'll talk more about it later on. And this is something optional for the regular tables, and we cannot specify it for a regular table either. Then the last thing we have is constraints, whether we want to enable or disable a constraint in case if the constraint is getting created. So if we don't specify anything, by default all the constraints that we add while creating the table will be enforced. In case we feel that I want to create a constraint but I don't want to enable it immediately, but I would like to do it later point of time, then I can say that disable constraint so that it doesn't get enabled, right? So these are different properties that we have while creating the table. Video, we'll see all these commands practically by start creating a table, and then we'll try to use different data types, different data sizes, and then we will look at how much of memory, how do we check how many bytes the table has consumed or how many blocks how been assigned, and in case if we insert the data, how it gets extended. How do we check whether the table is compressed or not? All these things we'll be checking in the next video. Till then, take care. Bye bye.